Hi, I'm going to discuss some important questions from the chapter Matrices and Determinants of Grade 12 Mathematics. So first question you can note. If A and B are symmetric matrices, then prove that AB minus BA is skew symmetric matrix. Then prove that AB minus BA is skew symmetric matrix and AB plus BA is what? Symmetric matrix. AB plus BA is what? Symmetric matrix. What do you mean by symmetric and skew symmetric? A small idea I'll tell you. You know, symmetric matrix definition is a matrix, if you want to say symmetric, whose transpose should be same. Whatever things you have, if you want to say in the case of matrix, that transpose should be what? Same matrix. What do you mean by skew symmetric? A matrix, if you want to say skew symmetric, A transpose should be what? Negative of that one. To understand this one, suppose you have to consider this is a matrix, this one. If you want to say this is what symmetric, this transpose should be what? Same as the same thing. This is what we are calling. This matrix transpose should be same as the same matrix. So what we are calling this matrix is what? Symmetric. Now this transpose, if you are getting negative of this one, we people are calling what? Skew symmetric matrix. Don't forget it. So we can come to this one. Already what is given? If A and B are what? Symmetric matrix. So we can start. Given that A and B are symmetric matrix. Given that A and B are symmetric matrix. Therefore, what is the condition? Therefore, A transpose equal to what? A and B transpose equal to what? B. Equation number 1. This I took equation number 1. What we want to prove? We people want to prove AB minus BA is what? Skew symmetric. So first one, to prove AB minus BA is what? Is skew symmetric matrix. Skew symmetric matrix. AB minus BA, if you want to prove skew symmetric matrix, I told you, if you want to prove this one is what? Skew symmetric matrix, what is the condition? Okay, sorry. See, we want to show this is skew symmetric matrix. I told you, if you want to show a matrix is what? Skew symmetric matrix means that transpose. This we want to show what? Skew symmetric. This transpose should be what? Negative of that one. This transpose should be what? Negative of that one. We are checking that one, so proof. So we want to show this is skew symmetric, that transpose we should get what? Negative of this one. That only I told you. Let us see. In between many properties are there that will write. That already you know, but anyway I'll explain in between. So proof, listen. What will be? AB minus BA all transpose equal to, because we want to get this transpose is what? Negative of this one. That's what we are calling skew symmetric. So what? This one can be written as AB all transpose minus BA all transpose. We have a property A plus B all transpose can be separated as A transpose plus what? B transpose, like that minus also. But multiplication is not like that. AB all transpose is what? B transpose into A transpose, just like reversal law. AB multiplication all transpose is what? B transpose into A transpose. And one more thing is that AB and BA never get cancelled. By in general, matrix multiplication is not commutative. I'll give you more question, A plus B whole square and all. That we'll discuss afterwards. AB and BA is not equal, because matrix multiplication in general it is what? Not commutative, but matrix addition is commutative. A plus B same as what? B plus A. But AB is not same as what? BA. Difference also not commutative. You already learned that one. Now this case, this according to the reversal law, just now I told you, this we can write B transpose into A transpose minus A transpose into B transpose. In both the case I applied reversal law. From one, what is A transpose and B transpose is same as B, A transpose same as A minus A transpose same as A, B transpose same as B. So we got BA minus AB. This can be written as minus of AB minus BA. Minus of, so this transpose I got what? Negative of the same thing. So minus when we are taking out, you know, it will reverse. This transpose I got negative of this thing. That means what? It is what? Therefore AB minus BA is what? Skew symmetric. That only I told you. A matrix transpose is negative of that matrix if it comes. We people are calling what? Skew symmetric. That only I got in this case. Therefore AB minus BA is what? Skew symmetric matrix. Therefore AB minus BA is what? Skew symmetric matrix. Please pause the video and copy this one. Now second one is what? To prove AB plus BA is what? Symmetric matrix. AB plus BA is what? Symmetric matrix. What is symmetric matrix? That transpose should be same the thing, same matrix. So we can see this transpose plus everywhere same thing only, and here also plus. I told you before, matrix multiplication is what? Matrix multiplication is what? Commutative. So BA plus AB we can write what? AB plus BA as well. So this transpose what we got? Same thing we got. So what we can say? AB plus BA is what? Symmetric, and AB minus BA is what? Skew symmetric. Please pause the video and copy this one. Now we are discussing the second. Okay, second question. The diagonal elements of a skew symmetric matrix are 0. All the diagonal elements of a skew symmetric matrix is what? Matrix are what? 0. This is the question. Show that all the diagonal elements of a skew symmetric matrix are 0. It is asked in 2018 Gulf Board paper for 2 mark I think. All the diagonal elements of a skew symmetric matrix are what? 0. What do you mean by diagonal elements? Diagonal elements is applicable only for what? Square matrix. That is, in a square matrix I equal to j, that's what we are calling diagonal elements. For example, suppose a order 3, A11, A12, A13, A21, A22, A23, A31, A32, A33. This element we are calling what? Diagonal elements. Which one? I equal to j means what? A11, A22, A33, A44 like that. But it should be in a square matrix. That what we are calling what? Diagonal elements. In a skew symmetric matrix, we want to show the diagonal elements are what? 0. This completely 0. In a which matrix? Skew symmetric matrix. Okay, we can start. How will start? Try to understand what is the transpose and all. Aij will become what? Aji. This is a theory part. Just try to understand. This is the thing. Proof. Let A equal to Aij. You know how the matrix we are representing. Be a skew symmetric matrix. Be a skew symmetric matrix. This is the starting. Let A equal to Aij be a skew symmetric matrix. Be a skew symmetric matrix. What we want to prove? To prove all diagonal elements are 0. That means what? A11, A22, A33. That is 0. In general, we can call Aii equal to 0 or Ajj equal to 0. Aii means A11, A22, A33 like that. So to prove all diagonal elements are 0. So already we have, this is what? Skew symmetric matrix. Therefore what we can say? Therefore given that A is what? Skew symmetric matrix. Therefore what we can say? Just now I told you A transpose equal to what? Minus A. A is this one. So A transpose will be what? Aij transpose equal to what? Minus of Aij. You have tried for all possible values for all possible values of what? I and j. For all possible values of what? I and j. For all possible values of what? I and j. You are right neatly and properly. For all possible values of what? I and j. So transpose, if it is comes, you know it will become what? Aji equal to minus of Aij. Why Aj? Transpose, you know, A23 will become what? A32. Number of, if a matrix order is 2 by 3, then it will become what? 3 by 2. So the position will change. A12 will become A21, A32 will become A23. That's why. For all possible values of what? I and j. But we people want to prove what? Diagonal elements. All the diagonal elements are what? Elements. This is what? Matrix. This is the representation of the matrix. Elements, when we are writing that square bracket won't be the. You please write for diagonal elements I equal to j. For diagonal elements I equal to j. Only now I am telling elements. This is what? Matrix. This everything is matrix. because the bracket is there. For the diagonal elements I equal to j, that is what? I equal to minus of I for all possible values of I. Why? Because diagonal elements, now elements, not the matrix. That square bracket I removed. For diagonal elements, what we can call? I equal to what? J. So either you can write AJJ, both side AJJ, or you can write what? AII. Now you can bring this side, minus AI when we are 2 times AII equal to 0, AII equal to 0 for all possible values of I. For all possible values means in a square matrix the possible 1, 1, 2, 2 like that. So AII equal to 0 means what? What do you mean by AII? A11, A22, A33 like that. So AII equal to 0 is what? Diagonal elements are what? 0. So conclusion will be, already we took this is which matrix? Skew symmetric matrix. That is all the diagonal elements of this skew symmetric matrix are what? 0. Proved. I hope you understood it. Repeatedly write and practice, pause the video and copy this one. Okay. Now third question after this. Third one. Show that a matrix which is both symmetric and skew symmetric is a 0 matrix. A matrix which is both symmetric and skew symmetric is what? It should be a 0 matrix. Okay, let us start. Given that let A is both symmetric and skew symmetric. Let the matrix A be both symmetric and skew symmetric. So there is a matrix that is A. It is what? Symmetric as well as skew symmetric. That's why that is therefore A transpose equal to A, because what? Already they told the matrix is what? Symmetric means their transpose will be what? Same. And A transpose equal to what? Minus A. Equation number 1. Sorry, this is 1. This I took 2. Why I wrote here transpose equal to A? Because A transpose equal to A symmetric as well as what? Skew symmetric. So from 1 and 2 what you can say? Their left side are equal. So from 1 and 2 what we can say? If the left side is equal, right side also equal. From 1 and 2 what we can write? A equal to what? Minus A. You bring this side. What will be? A plus A equal to 0. 2A equal to 0. A equal to 0. A equal to 0 means what? It is what matrix? It is a skew symmetric matrix. Sorry, 0 matrix. So proved. A matrix which is both symmetric and skew symmetric, it should be what? 0 matrix. I hope you understood this one. Now, okay, fourth question. Prove that the determinant of a skew symmetric matrix of order 3 is 0. Determinant of a skew symmetric matrix of order 3 is 0. Determinant of a skew symmetric matrix of order 3 is 0. Determinant of a skew symmetric matrix of order 3 is 0. Which matrix? Skew symmetric. Right on. Let A be a skew symmetric matrix of order 3. Let A be a skew symmetric matrix of order 3. Please underline order 3. Let A be a skew symmetric matrix of order 3. Please underline what? Order 3. What is skew symmetric? That is A transpose equal to what? Minus A. I told you what do you mean by skew symmetric. Question is not like, question is not that one. Determinant of a skew symmetric. So take a determinant on both sides. Determinant of A transpose equal to determinant of minus A. Don't confuse, it is not a modulus, it is what? Determinant. You already know a matrix determinant A and determinant A transpose is what? Same. That you learned already. Not only that one, determinant of K, sorry, this one also you know. A scalar quantity into matrix, that determinant if you are finding, it will be what? K raised to n into determinant A, where n is what? Order. Important question, we'll do that. Where n is what? Order, don't forget it. So here what we can apply? Determinant of A transpose equal to what? Determinant A. And this what? Minus 1 is there. Order, I already told you, order is how much? 3. So minus 1 into A. So K value minus 1 into A, that determinant will be, that scalar quantity will come out with the order. So here what will be? Minus 1 raised to what? 3 into determinant A, according to this definition. According to this definition, k is minus 1, so minus 1 raised to n. Your order is how much? 3. So what we can write? Determinant a equal to what? Minus 1 cube minus 4 minus of determinant a. So 2 times determinant a equal to what? 0. Determinant a equal to what? 0. So what we got? Determinant of actually odd order we are telling. Determinant of this one, order 3 is what? Skew symmetric. A is a skew symmetric. Determinant of a skew symmetric matrix of order 3 is what? 0. This also we got. I hope you understood this one. In between some general questions I am discussing. What is a plus b whole square? In general, you know, a plus b whole square is what? A square plus 2ab plus b square. But in the case of matrix multiplication is not commutative. So you people have to write a plus b into a plus b 2 times you have to write. Don't use what the general thing, because matrix multiplication is not commutative. Now you have to open a into a square, a into b ab, b into a ba plus b square. This will be the result. AB and BA is not same in the case of matrix multiplication, but in the case of scalar case, okay, but matrix multiplication is not same, so this will be the answer. Now what is a square minus b square? Sorry, what is a plus b into a minus b? A plus b into a minus b. In general thing, we people are writing what? A square minus b square, but in this case we can't write that one. We can see a into a square, a into this minus ab. Is it a into minus b minus ab, b into a ba, and b into minus b square, this one. But in general case, what we are doing, ba and minus ab get cancelled, but in the case of matrix multiplication, ab and ba are not same, so this will be the answer. I hope you understood this also. Okay, next one. If A is a square matrix such that A square equal to I, if A is a square matrix such that A square equal to I, A is a square matrix such that A square equal to I, then find the simplified value of A minus I whole cube plus a plus I whole cube minus 7a. A minus I whole cube plus a plus I whole cube minus 7a. Now important question from the matrices and determinants I am sharing. Already inverse trigonometry some questions I given, and relations and functions also will share, and this one differentiation also will share. So we want to find the value of this one, simplified value of that one. So how will start? The starting will be given that a square equal to what? A square equal to what? I. Already we have a square equal to what? I. Then what about a cube? Therefore a cube we can write a into a square. Already we have a square is what? I. So ai is what? A. Any matrix into identity matrix is what? It will be A. So ai equal to what? A. Everything square matrix only, don't forget it. So this is already a cube. Why I found a cube, I'll tell you. So our question is a minus I whole cube plus a plus I whole cube minus 7a. What is a minus b whole cube? You know a minus b whole cube result. A minus b whole cube is what? A cube minus 3a square b plus 3ab square minus b cube. This result we have. So don't forget a minus b whole cube and a plus b whole cube. We have first a minus b. Okay, that we have a plus b whole cube. If it comes completely, will be what? Plus. So that I am going to apply here. This will be a cube minus 3a square I plus 3ai square minus I cube plus, here also we have to apply a cube plus 3a square I plus 3ai square plus I cube minus 7a. For cancellation we can do which one? 3a square I we can cut. I cube and minus I cube we can cut. What is a cube? A cube already we found it is same as what? A cube is same as what? A. So if you want you can call a square is the square is not there, no? So this we can call 1. A cube equal to what? A. So what? A cube is what? From 1, A plus 3A. Why? I square, I cube, I raised to for everything is what? I. This is I only. AI is what? AI is what? A. You know that. So this is over. A cube is what? A. And I square is what? I know. So AI will be A. So again 3A. Down if it is there you can ask. Minus 7A. So A plus 3A 4A 5A. 5A plus 3A 8A. 8A minus this will be what? A. That will be the answer. This will be the answer. Please check it. Any problem if it is there you can check. Okay. I hope you understood that also. Next one. The question please note. If A is a square matrix of order 3, if A is a square matrix of order 3, and the determinant of 3A equal to, order is what? 3, and determinant of 3A equal to K into determinant A. K into determinant A. What is the value of K? What is the value of A? Just before I told you about this one, just 1 minute. Before I told you about this one, K in Ka determine this one, K raised to N into determinant A, where N is what? Order. So left side here order 3 already we mentioned. So what will happen? This 3 will come out with order. 3 cube into determinant A equal to K into determinant A. Left side I applied this result. So determinant A we can cut K equal to how much? 27. I hope you understood this one. K equal to how much? 27. Please copy this one. After that, next question. If A and B, you have to pause the video and copy it. Otherwise, a lot of time will take. Next one. If A and B are square matrices of order 3, if A and B are square matrices of order 3, if A and B are square matrices of order 3, and determinant A equal to 5, determinant of A equal to 5, determinant of B equal to 3, determinant of B equal to 3, find the value of determinant of 3AB. Find the value of determinant of 3AB. Very simple only. Order 3. See, determinant of 3AB they are asking. So there is a numerical value. The order is what? 3. So what happened? 3 cube into determinant of AB will come. Because here this scalar value is there. That will come out along with what? The order. And the determinant of AB, we have a property. Determinant of A into determinant of B is same as what? Determinant of AB. Like that property we have. So this can be written as 27 into determinant A into what? Determinant B. That is 27 into 5 into 3. Because already we have, I think 405. Please make sure the calculation is correct or not. That you have to make sure. Don't forget it. Okay, I hope you understood this also. I think you wrote it. Next one. You have to pause the video and you have to write it. Next question. If A and B are square matrices of the same order, if A and B are square matrices of the same order, if A and B are square matrices of same order, A and B are square matrices of same order, such that determinant A equal to 6, and AB equal to I, and AB equal to I, then write the value of determinant B. Okay, we'll start. Given that this and this, we have AB equal to I, take determinant on both sides. What will be determinant of AB equal to what? Determinant of I. Determinant of AB, just now I told you we can separate it. What? Determinant A into what? Determinant B. What is determinant of I? Identity matrix always the determinant of which one? That also you know. You know determinant A how much? 6. 6 into determinant B equal to 1. What is determinant B? 1 by 6. See, easily we got it. And the two matrices when we are multiplying I, you should get, that is I means identity whose determinant is what? Identity element, it will be 1. So 6 and 1 by 6 will be 1. Like that also 1 mark if it comes. Identity 1, A into B you should get 1. One number should be 6, other number should be what? Like that you can think about. Because determinant is what? Is a unique value associated with a scalar matrix. Determinant is always a unique value associated with a square matrix. Associated with a square matrix. Don't forget it. Okay, next one. I hope you finished this also. Next one, please note. If A is a matrix of order 3 by 3, if A is a matrix of order 3 by 3, if A is a matrix of order 3 by 3, if A is a matrix of order 3 by 3, and A into adjoint A, and A into adjoint A equal to A into adjoint A equal to 5i, then find determinant of adjoint A. Determinant of adjoint A. You know adjoint A is a matrix, but determinant is what? Is a unique value. So before starting this one, you have to write, you know, a matrix and its adjoint, when we are multiplying, always will get determinant A into corresponding identity matrix, and that is equal to what? Reverse also, adjoint A into what? A. I told you in general matrix multiplication is not commutative, but this case A matrix and whose adjoint if it is there, that is same as what? Adjoint A into A. In this case matrix multiplication commutative because one is the related to other, adjoint A. So that property we have. So this left side, given that this, we want to, so A into adjoint A, what we can call? A into adjoint A we can call what? Determinant A into I equal to 5i. Determinant A into I equal to 5i. I cancel. What is determinant A? Determinant A equal to 5. Determinant A equal to what? 5. But question is not that one. Question is what? Therefore, there is a result, another result. How it comes, I am not explaining now. If anybody needs, we'll explain. I think already some video I shared with you. Determinant of adjoint, those who asked it. Determinant of adjoint A, this is the result. Determinant A raised to n minus 1. Determinant of adjoint is what? Determinant A raised to n minus 1. Determinant A we have 5. And n means order. Already mentioned the order is what? 3 by 3. So 3 minus 1. So how much? 2. So the answer will be how much? 25. Please pause the video and please complete. Okay, next one. Next question. If A is a square matrix of order 3, if A is a square matrix of order 3, if A is a square matrix of order 3, and determinant A equal to 3, determinant A equal to 3, then find determinant of A into adjoint A. Determinant of A into adjoint A. This is the question. Then find determinant of A into adjoint A. That we want to find. So this we want to find. So this can I write? Already I told you two matrices determinant you can separate it, determinant A into determinant B. Here A is a matrix, adjoint A is also a matrix. So this can be separated as determinant A into what? Adjoint of A. Like that we can separate. So what is determinant A? Okay, fine. Determinant A. What is determinant of adjoint A? In the previous case I given, determinant of adjoint A is what? Determinant A raised to n minus 1. So determinant A raised to n minus 1 will come. Here determinant A one time, here n minus 1. So it will be what? Determinant A raised to n. This I just explained. Actually directly you can write this result. So what is determinant A here? 3. What is order? That's also 3. So the answer will be how much? 27. How we are getting the result? I just explained that only. Please copy this one. And the last question I'm going to conclude. The last question. If A is an invertible matrix of order 3. Invertible means we can find inverse. Every matrix sometimes we can't find inverse. That is non-singular and singular matrix. You already learned that one. Okay. Please write. If A is an invertible matrix of order 3, if A is an invertible matrix of order 3, if A is an invertible matrix of order 3, and determinant A equal to 7, and determinant A equal to 7, and determinant A equal to 7, then find adjoint of adjoint A. Then find adjoint of adjoint A. Adjoint of adjoint A. What do you mean by adjoint of adjoint A? Adjoint A is a matrix. How to find adjoint, you know, minor cofactor like that we are finding. So that adjoint A matrix, once you find, again you have to find adjoint of what you got. It is a matrix. It is not what? Determinant. Determinant always want a unique value. That's a 2 lines will be there. It is a matrix. So the result, we want to find this, the result, determinant A raised to n minus 2 into A. This will be, because determinant A raised to n minus 2, it is what? Scalar value and unique value into A. Result, don't forget, already it is there in your book sheet. So what is determinant A here? 7, no? So 7 raised to orders 3, 3 minus 2 into A. That is what? 7A will be the answer. It is a matrix, 7A. A is a matrix, 7 into that matrix. So I hope you understood this one. Now, many important questions are there still that we will discuss later. And anyway, this is for 1 mark, 2 mark like that. Sometimes they can ask. So I hope you understood this part. Now, after this one, people will discuss which one. Relations and functions, some important question later. I hope you understood. Repeatedly practice it and don't forget. Okay, that's all. Bye.